Hello everyone, welcome to the fourth video on the Snowpro core certification crash course series. In this video, we are going to discuss about object hierarchy within Snowflake, and then we are going to discuss about databases, schemas, varieties of tables and varieties of views within Snowflake. When we talk about Snowflake's object based hierarchy, this is the one which is present in the Snowflake documentation. This very well represents the Snowflake's object hierarchy in a very detailed way. If you see it at the top, there is something called as the organization, which is the starting point of Snowflake, and then within the organization we can have something which is called as an account. Within the account we can have a virtual warehouse, we can have database, we can have roles, we can have users, and then we can have some other account based objects. Within the database, it can be segregated into two parts, typically a database role, which is all about the role based access control, which will be discussed in the subsequent videos. And then there is something called a schema. So within database we are having schema, and within the schema we are having all the base level objects, say like table or a view or a stage or a stored procedure or a user defined function and other schema based objects. So this is the overall object hierarchy within Snowflake. So it starts with organization, account, and then database, schema, and then within schema we will be having varieties of objects. This is represented in this way as well, as a form of a concentric circles. So if you can see, the bottommost circle is the schema objects, and then it is contained within the schema, that is contained within the database, that is contained within the account. Now moving on, we are going to discuss about each and everything which we discussed earlier: account, database, schema and schema objects in a detailed manner. When we talk about account, anyone can have any number of accounts. Say I am an user of Snowflake, or I am an organization which is using the Snowflake, I can have any number of Snowflake accounts. Each account can have its own URL. That URL representation we are going to discuss at the bottom. Each account is deployed on one single cloud service provider, AWS or Azure or GCP, meaning we can have one Snowflake account on any one of the cloud service provider only. We cannot have a Snowflake account which is deployed across cloud service providers like AWS and Azure, Azure and GCP, or AWS and GCP, like that. Each account exists in single geographic region. This is again an important point to know. Within any cloud providers, we can have something called as a region, which is the place on which their data centers are located. So each account exists within one geographic region only. Each account exists in single Snowflake edition only, meaning I cannot have an Snowflake account which has both standard and enterprise. I need to create my Snowflake account with one edition, meaning I can have an enterprise, I can have a standard, I can have business critical, I can have VPS. I cannot combine both together into one single Snowflake account. Now coming to the account name format, this is the one which is newly introduced by Snowflake. So this needs to be clearly understood. You can see HTTPS followed by organization name followed by account name .snowflakecomputing.com. The organization name and the account name will be combinedly identified as account identifier. Earlier, we are having the legacy ways by which the account name format can be represented. The legacy one is something like this: account followed by region followed by cloud provider. So all these things are combined together and it is represented as the account identifier. So this is also prevalent now. This is the legacy way of representing it. As the organization got added to the Snowflake hierarchy, they are adding organization as the part of the account name. And if you are having a trial Snowflake account, it is usually in the form of XYAB, meaning first two letters followed by 5 numbers. That is how the Snowflake trial account name is represented as. But anyway, trial account can be converted to paid accounts as well. In general, these are all some of the details about the account on the Snowflake. Moving on, we are going to discuss about the database things on Snowflake. Accounts contain databases. This is the known thing which we already discussed. And then the high level in the namespace. What is the namespace that we are going to discuss in the subsequent slides? It contain one or more schemas. So same, there is nothing new here. If you understood the hierarchy in proper way, account can contain multiple schemas. Organization can contain multiple accounts. Accounts can contain multiple schemas, multiple databases as well, right? And then you can see default Snowflake database contain information about the account usage. When you create a Snowflake account, if you see in this diagram, there are two default databases which got created. One is the Snowflake database, other is the Snowflake sample data database. So this Snowflake database contains the information about the account usage. Snowflake sample data contains some data which can be used for educational purposes. So this diagram clearly represents the detail about the databases here. This is the one which I took it from the typical web UI interface of Snowflake, which is the Snow site. Here you can see databases. Inside the databases you can see list of databases, and then within the database you can see database details and then the schemas as well. Moving on to the third level of hierarchy, which is the schema. Schema contains objects as simple as it is tables, views, stages, file formats, etc. This provides the logical grouping one level above the objects. As simple as it is mainly used for grouping. It acts as the folder for database objects, easy to group and locate specific data. Meaning I am having a specific set of data for a specific purpose. Then what we can do, we can create the schema for those specific set of data which can be grouped into a common folder type of a mechanism. That is the usefulness of the schema. It is owned by a specific account or a role. It is as simple as it is. It will organize related data objects within the database. Why? Because within the database we can have multiple schemas. So schemas provide the logical grouping. Now comes the namespace part. As we do whenever we are doing SQL queries against the tables or views in Snowflake, it is always needs to be represented in the namespace, meaning database.schema.schema.object. Say if I am going to represent a table, I will represent it as the database name .schema name .table name. And then there is another important thing, as we discussed in the databases section. There are some schemas which got created by default by Snowflake. One is the public schema and other one is the information schema. Information schema holds the metadata tables which are useful to understand various things like how much storage it is consumed, how much credits it got consumed. All these details are available in the information schema, and also the public schema is the place where all the public assets are stored. Public assets meaning the data which can be visible for everyone who is having access to that specific account or the specific schema. That is called as the public schema. In general, it is the publicly available data. So this screenshot represents the details within the databases. If you see, this is the schemas, and within the schema you can see account usage schema, alert schema, core, all these things are available. Moving on to the final section of this hierarchy, which is the schema objects. This is the lowest level in the hierarchy. It contains all the important thing, meaning all the baseline data is available in this schema objects section. So tables, views, stages, file formats, pipes, streams, tasks, user-defined functions, store procedures and sequences. Everything is available. This diagram is a clear representation of it. If you can see, my database is the database. Inside that, the my schema is the schema, and inside the schema you can see my first table, my second table. Similarly, you can see Snowflake is the database. Inside it you can see the account usage, and then inside it you can see the views and functions and everything. So this complete stuff will provide an overall overview on how the objects are getting stored inside the Snowflake ecosystem. Now we are going to discuss about the schema objects within Snowflake. As we discussed earlier, the schema objects is the last level in the object level hierarchy, which holds all the permanent information of data in the form of tables, views, stored procedures, UDFs and everything. Now, with respect to the tables on Snowflake, there are 6 different varieties of tables which are currently available, which is permanent table, temporary table, transient table, external table, followed by iceberg tables and hybrid tables. These two, iceberg and hybrid, are on preview mode now. Possibly it will be generally available in the near future. We are going to discuss more in detail about all these tables. Coming to views, there are 3 different set of views which are available in Snowflake. Standard view, aka also known as a view. When we represent a view, it is a standard view only. There is something called as a secured view, and there is something called as a materialized view. Again, we are going to discuss in more detail about the views as well in the same video. Coming to the stages part, there are 3 different stages within Snowflake: table stage, user stage, named stage. Named stage is further categorized into named internal stage and named external stage. Named external stages are typically the stages which are in the outside of Snowflake ecosystem, typically on the AWS S3, Azure Blob, and GCS buckets. And then there are some other things which are commonalities between these stuff. Commonalities meaning these are all the ones which are part of the schema objects. So file formats are there, sequences are there, store procedures are there, user defined functions are there, streams are there, tasks are there, pipes are there. So no need to worry, we are going to discuss more in detail about all of these things which are discussed as the part of this specific diagram. Moving on to the table types. As we discussed earlier, there are 6 main categories there. In this diagram, we are seeing only 4 types. Regarding the iceberg and hybrid, we are going to discuss in the subsequent slides. We can go in the horizontal way first, trying to understand what they are going to offer. Permanent tables. Permanent tables are the standard ones in Snowflake. It is the default table type. Meaning, if you don't define the table type while creating the table, automatically it will be created as a permanent table. It is the most common one which is used everywhere. Typically in the databases, in the data warehousing background, all the data will be stored in the form of the tables only. So this is the permanent way of storing the data. It exists until it is permanently dropped. It's a common mechanism. It's a common fashion for any of the table. The tables will live until it is dropped explicitly using the drop table command. Moving on to the temporary tables. Temporary tables are a pretty tricky and an interesting feature to understand. It lasts only for the specific session. Meaning, if I can terminate the session or else if I can log out from the specific session, whatever the tables which are defined as the temporary will be dropped automatically. All the data which is lying within the temporary tables as well will be dropped automatically. So that is very important to know. It is the transient one in nature. So try to understand the tricky part is temporary and transient. Obviously, it is the transient one which stores the data for the temporary duration of time. That is the reason why they named it as the temporary table. What is the use case for the temporary table? Typically, the use case is all about moving the data from one of the permanent table to the other permanent tables with some transformations. Say I am having a table A and I am having a table B. From table A to table B, I want to do some data transformations. In that space, what I can use the temporary table intermittently to do the transformation. I can do some transformations on table A and store the data temporarily on the temporary table, and then again from the temporary table I can take the data and I can put the data into table B. This is how it is useful. So once the session is lost, that temporary table will also be dropped off. Moving on to transient tables. The transient tables are the ones which are more or less as similar to permanent table. You can see it will exist until permanently dropped. This is the same fashion as for the permanent table as well. It is less costly than the permanent table. Why? Because the file save option is not there, that we are going to discuss at the bottom. Moving on to the external tables, it is like it stores the data outside of the Snowflake. Typically in any of the cloud storage mediums like S3 or Blob or GCS buckets, these are all read only. Why? Because the data is there in the cloud storage medium, it is not natively stored within the Snowflake. So obviously we can do only DML operations. Typically select, aggregations and joins are the DML operations there. It can be used as a view as well, meaning we can create a view on top of the external tables. The cloning option is not available with the external tables. So this provides an overview about what these four tables are. Now coming to the important factor for the exam and also for our understanding point of view, for time travel, how these tables are going to behave. If you see time travel in the permanent table, for the standard edition of Snowflake, we can have maximum of 1, meaning we can do time travel on the permanent table which belongs to the standard edition of Snowflake. We can have maximum of 1 day alone. We can make it to 0 as well. 0 meaning disabling the time travel option. We don't have any way to time travel on the data. If you set this parameter as 0, default parameter is 1. Now when we are using the enterprise edition of Snowflake, then we can have the maximum flexibility to define the time travel from 0 to 90, meaning from 0 to 3 months we can define the time travel. If your enterprise or organization is very keen on the regulatory requirements, like I want the data to be stored for 2 months or 3 months or so, then the enterprise edition of Snowflake will be the correct one, which provides the option to do a longer duration of time travel. So we need to be very much aware about all these things. So time travel is possible with the permanent table with these versions. When we move on to the temporary table, the only option is 0 or 1. So maximum of 1 day time travel is only possible for temporary table. Similarly for the transient table, maximum of 0 or 1, maximum of 1 day of time travel is only possible. When it comes to the external table, time travel option is not at all available. So tick marks is all about availability, cross mark is not all about non-availability. Moving on to fail safe. What fail safe is all about? It is an additional mechanism provided by the Snowflake to store the data beyond the time travel. I had already put together a video with respect to the time travel and fail safe. I will add the description for that video to this video as well. But again, as the part of the course curriculum, we will be seeing more in detail about the time travel and fail safe in the subsequent videos. Now coming to the permanent table, if you see, 7 days of fail safe is available, which is fixed, meaning we cannot configure, we cannot change this to 1 or 2. It will be 7 days as fixed as it is. It is completely managed by Snowflake. That is the fail safe for permanent table. When it comes to temporary table, there is no fail safe mechanism. When it comes to transient table, there is no fail-safe mechanism. So, for better understanding, transient is more or less same as permanent, which is different in these two areas. Typically, on the time travel, maximum of 1 day time travel, and there is no fail-safe which is available for transient tables. Obviously, for external tables, the fail-safe option is not available. When it comes to cloning, cloning is an interesting feature. Again, we are going to discuss more in detail in the subsequent videos. Cloning is available for all these three tables, permanent, temporary and transient. It is not available for the external tables in Snowflake. Now moving on, we are going to discuss about the pending two different set of tables which are available within the Snowflake. The first interesting type of table is the Iceberg table. As we already discussed, currently the Iceberg table is in the preview mode alone. So what is Iceberg? It's an interesting question to answer. There are different set of data lake file formats which are available. Typical data lake file formats are Delta Lake from Databricks. Apache Hudi is an data lake file format, and Apache Iceberg is another data lake file format which is currently available. All these things are open source file formats, so we can utilize these file formats and implement the typical acid based mechanism, schema evolution, hidden partitioning, and table snapshots using these typical data lake file formats. So Apache Iceberg is one quite an interesting and good open source file format which we discussed. So what Snowflake did, Snowflake provides us the opportunity to utilize these Iceberg file formats within the Snowflake ecosystem. That is what we call it as the Iceberg tables. So typically it is more or less similar to the external tables, meaning all the data lies in the cloud service provider ecosystem only, typically S3 or Azure Blob or GCS buckets, and the metadata and all the other relevant informations are available in the Snowflake ecosystem. So as we already discussed, these are all the typical advantages of using the Apache Iceberg. So we can combine the performance and query semantics of regular Snowflake tables with the external cloud storage. That is the greater advantage of using the Iceberg tables. It is ideal for existing data lakes, as I told earlier, that you cannot or choose not to store the data in the Snowflake. So I am having an existing data lake which is lying in S3 in typical Apache Iceberg or something. So how I can take it into Snowflake? Iceberg tables are the ideal way to do that. Snowflake support Iceberg tables that uses Apache Parquet file format alone. This is very important thing to know. As of now, Snowflake supports Iceberg only for Apache Parquet file format. So how it works? What are all the various parameters which needs to be tuned to enable this Iceberg table within Snowflake? There are some key things which are laid out in the Snowflake documentation. I just try to consolidate those things together. As we already discussed the data storage part, this is not part of Snowflake anywhere. It is going to be S3 or Blob or GCS buckets. Once that is there, then we need to create the external volume. External volume is all about the role management, IAM access roles and everything, which will allow Snowflake to access the data which is stored in the external storage. Moving on, there is something called as an Iceberg catalog that is very important, which enables the compute engine to manage and load the Iceberg tables. That can be done in Snowflake by two different ways. Using Snowflake as the Iceberg catalog is the one mechanism, and using the external Iceberg catalog is also possible using the catalog integration option. And then the metadata and snapshots are very important for Iceberg. Why? Because Iceberg uses the snapshot based querying model where the data files are mapped using the manifest and the metadata files. So a snapshot represents the state of the table at a point in time, and it is used to access the complete set of data files in the table. So the metadata and snapshots are very important. So we need to manage these things as well within the Snowflake ecosystem. When it comes to the cross crowd and cross region support, it depends upon the type of the Iceberg table which we are going to use. And for the building, if you know, only for the virtual warehouse compute usage we are going to be built. There is no cost for storage. Why? Because the data is already stored in the cloud storage like S3 or Azure or GCS buckets. So for the Iceberg, if you see, this is the typical one from the Iceberg. This is the Iceberg architecture, how it works. If you see at the bottom, there is the data layer where all the data files are there. On top of it, it works based on the manifest file. That will be the main feeding mechanism for the metadata file. And then on top of it, we will be something called as the Iceberg catalog. This is what which we discussed earlier as the part of the discussion as well. When it comes to the Snowflake documentation, if you can see, whatever which is there, it is mentioned here. So data storage, Iceberg catalog, metadata and everything. So how to do so, all these things are clearly mentioned as the part of this documentation. So it's like how we can maintain the metadata using the data retention time in days parameter. These are all something which is very important. So using the typical Snowflake as the catalog versus the external catalog using using the catalog integration, what are all the features which are available, and how the cataloging option differs between the Snowflake as Iceberg catalog and using the external catalog. It provides what are all the various features. So glimpse through this documentation. If you see these are all very very good pictures. So using Snowflake as the Iceberg catalog, if you see external storage is there, on top of it we create an external volume and we maintain the Iceberg table within the Snowflake. So this box is the Snowflake where we can maintain the Iceberg catalog and metadata and everything. So if you see the external catalog, typically Snowflake don't maintain any of the cataloging, that is maintained externally apart from the Snowflake ecosystem. So using the catalog integration, we can take the external catalog and feed it into the existing Snowflake systems. This is very good. So please go through this document. I will add the link for this documentation in the description of this video. Moving on, we are going to discuss about something called as a hybrid table. This is again an interesting and very good feature within Snowflake which got recently introduced. There is a term called Unistore which we discussed as the part of the initial Snowflake architecture. It provides an opportunity to combine both the columnar and the row level way of storing the data. How it is possible? We already discussed Snowflake stores the data in the compressed optimized columnar storage which helps in the analytical data processing. That is the description which we saw as the part of the storage layer. Now we are trying to make a tricky part out of it. Snowflake provides the opportunity to store the data in the row based manner as well. That is the reason for the introduction of hybrid tables. So it is optimized for hybrid transactional and operational workloads. Typically for the transactional workloads, we need to store the data in the row-wise way for speed processing and everything. It provides the low latency and high throughput for small random point reads and writes. It supports unique and referential integrity constraint enforcement. This is again an interesting feature to know. Why? Because in the normal Snowflake, we don't support or we don't enforce any constraint like the uniqueness or referential integrity. Unistore, as we already discussed, it is used to fit the other Snowflake table to bring the transactional and analytical data together in the single platform. I hope you are able to understand this in a clear way. Say I can have a table which is in the columnar way, I can have a table which is in the transactional row based way. I can have the option to combine both these tables in the form of a join, in the form of a view or anything. That possibility is opened using the Unistore. So leverage a row store as the primary data store to provide excellent operational query performance. Right? Writing to the hybrid table, data is written directly to the row store. Some data may be cached in the columnar format to provide better performance on the analytical queries. This is again an interesting feature. Even though if you store the data in the row based way, Snowflake can utilize the caching features. It will cache some of the data in the columnar format so that it can be beneficial for the query performance of the analytical queries. So SQL against the logic hybrid queries, Snowflake query optimizer decides where to read the data from and provide the best performance. That's how the Snowflake query optimizer is designed. So it knows the least execution path and it will take the data accordingly. So this is the diagram which I got from the Snowflake documentation, which is quite useful. You can see the top two layers are same fixed as we discussed in the architecture diagram, cloud services layer and query processing layer. If you see at the bottom, there are two different ways by which you can do. Say these dots are in the vertical way, meaning these are all columnar based storage. If you can see hybrid tables where you can see the horizontal rows as well, which are all row based storage, so you can combine both the row and columnar together. That is the reason behind the introduction of the hybrid tables. This future comparison matrix is quite an important thing. If you can see the difference between the standard tables and hybrid tables, the primary data layout is row oriented with secondary columnar storage. Here it is only columnar micro partitions. Locking is row level locking. Here it is partition or table level locking. Primary key constraints are required for hybrid tables, that is again important. Here primary key is optional. You might be aware of the primary key constraints. If you are from the data warehousing background, we uniquely define one of the parameters within the table as the primary key. So that is very well needed for the transactional based databases. So that is required for hybrid table. Apart from that, foreign key constraints, unique constraints, not null constraints and indexes are supported and optional for the remaining ones. To provide a greater overview, let's go through the typical Unistore and everything. So this is again from the Snowflake documentation. If you can see, as we discussed earlier, here there is a mention of index. If you create or replace hybrid table orders, order key, item key, order status, order date, customer name, there is a mention of index O order date with order date as the primary key, meaning this order date is the primary key for this specific row based table. That is how we can define the referential integrities within the typical hybrid tables. And also I am having the detailed documentation which talks about the use cases where we can use the hybrid table instead of the standard tables, determining when to use the hybrid table. All these details are very important from the exam point of view. So please glimpse through this documentation to get the complete overview about the hybrid tables. Moving on, now we are going to discuss about views. We completed all 6 different set of tables so far. Now we are going to discuss about different set of views which are available within the Snowflake. This is not that much complicated as tables. We are going to have only 3 different view types here. Those are standard, materialized and secure. I just put together the create view statements over here for the better understanding. If you can see, create or replace view, this one, no need to worry. This is the typical database name followed by this is the view name there. So all these things are common. Select star from demo 3db banking summary. This is the typical view definition. If you are not aware of what is view and all, view is just the abstraction on top of the table. Here if you can see, this banking summary underscore view, summary underscore view is the view which is developed on top of the summary table, which is just the select star from, meaning all the contents of the table are available as the part of this view. Now there might arise lot of questions, why I need to create like this. We are going to discuss more in detail about it, but this is the typical standard view. Standard view meaning standardized way of creating the view on the Snowflake. So this is the default view type, meaning if you don't define any specific keyword while defining the view, automatically it will be created as the standard view. DDL is available to any role with the access to the view, meaning if you are using any of the role which is having the access to the view, you can very well see the data definition language, meaning the schema related details for the specific view. There is no specific storage cost associated with the standard view. Why? Because views work in that fashion. Underlying data will be lying only in the table. The views are just the abstracted layer on top of the table. So whenever you fire a query against the view, obviously it will go and fetch the data from the table only. So there is no specific extra cost which is added for the view typically. Then now the source table is dropped. Say I am having the summary table, which is the source table, is dropped automatically. What it happens, it throws an error. Say my source table here, the summary table got dropped and I try to fire a query, select star from summary underscore view, it will throw me an error stating base table doesn't exist. So what is the ideal use case for this specific view? Now the statement shows select star from. Instead what we can do, we can create a specific elements or specific columns from the table and we can create a view on top of it. Then we can give the users access only to the view. By doing so, we can have the level of security abstraction. Instead of giving all the data to the users, we can give only the specific data from the table to the users via the view. This is the common use case which is prevalent in the industry for longer duration of time. I am just trying to say where these use cases is is going to be attached to the typical standard view. Moving on to the materialized views. This is something which is very important in Snowflake, which is very unique to Snowflake as well. Materialized view, how it is different using the single keyword which is materialized. While creating the view, create or replace materialized view, that's it. Apart from that, all the statement are same as the previous one. Now how it behaves from the Snowflake point of view, what they are saying, you can consider a materialized view as a table itself, meaning the data from the table will be manipulated according to the view definition and stored in the different location for the view. This will be very helpful in terms of the performance. Why? Because instead of going to the table and taking the data is already available within the view itself. That is the reason why this materialized view will provide you lot of performance benefits if you are trying to utilize the view. So this behaves more as a table. This is more or less as a table. Results are stored more or less like a table. It is auto refreshed, meaning whenever the base table got refreshed, the materialized view also got auto refreshed. It incurs more cost. I hope you can understand this. Why? Because it is storing the data in the duplicated way. Obviously for the view, one more addition of data needs to be stored, so it will incur more cost. It is inflexible and limited to use. Why? Because it is not that much flexible medium for usage. Again, as it add more cost to the ecosystem, this is more of an limited to use kind of an use case. Use case wise, you can see creating the materialized views for the external tables will enhance the performance. Now I hope you can understand, the external tables are the ones where the data is there in the cloud storage. So each and every time when you fire a query against the external table, it will leave the Snowflake, it goes to that specific storage location, take the data, come back to Snowflake, and then only it will provide the result. There is a lot of latency which is getting involved. Now if we can create a materialized view on top of that external table, obviously the data is stored within the Snowflake ecosystem, so the data latency and the query performance will be greatly enhanced. That is the use case for the materialized view. Moving on to the another interesting feature which is called as the secured view within Snowflake. How it differs based on same secure command while creating the view, but you can see there is an interesting thing which is added as the part of the view definition. Select w.star from widgets as w, where w.id in, select widget id from widget access rules as a, where upper of role name equal to current role. Meaning, how I can interpret this statement, this is as simple as it is. Widget access rules is the table where I am having all the roles which are allowed to access this specific view, widgets underscore view. Now if my current role, the current role command will be the current role which is part of that session. So whatever the role using which I logged into that session, if my current role matches the record which is already there in widget access rules, then only it will allow the person to view this widget's view. If the role is not part of that specific table, it will not allow you to access it. Now I hope you got a fair understanding. It provides an additional layer of security on top of the view. It will allow only the specific users alone to see the data within the view. Underlying query definition and details are visible only to the authorized users. That is how we implemented this. Using this view definition, I hope you can understand this statement. Not as fast as normal views. Query optimizer behave differently. Why? Because query optimizer will do all these mechanisms. Say it's a secure view, then what are all the roles I need to give access to? All these internal mechanisms will be dealt by the query optimizer. That will add more latency in terms of the query performance. Can be used with both the standard and materialized view, meaning I can create a standard view and also the materialized view as a secure view. So secure is all about adding the additional layer of security on top of the view. Hope you got a fair idea and understanding towards all the three different views which are available within the Snowflake. With respect to the future comparison, this is typically predominantly for the materialized view, which is part of it. So if you can see all these things, performance benefits, security benefits, simplifies query logic, clustering, storage, and then uses credits for maintenance, everything is tick for the materialized view. That is the very important thing to know. So if you want to achieve more performance and anything, you can utilize the materialized view. And the other things, if you can see how the regular view behaves compared to the regular table, regular view don't have the clustering options and the storage and all. Cached query results are available for the performance benefits. So the external table don't have any of the options. The same is available to us in the form of the documentation here. Again, I will add this specific documentation in the description of this video, where you can see all these things, how the each and every view is completely different with the other, and example use cases of materialized view, how query optimizer will utilize the materialized view for the given queries, etc. Right? So with this we come to the conclusion of this video. I hope this video has been informative for you. Please do write lot of comments so that I can enhance the contents and also my typical videos accordingly. Thank you very much for watching this video.